Hello, welcome back to Learn Physics. Today also the continuation of the revision topic, that is system of particles and rotational motion. So in last video I did tell the principle of moments, and today I am starting with couple. What is a couple? Couple is the two equal and opposite forces. If two equal and opposite forces which don't have the same line of action, don't have the same lines of action, will constitute a couple. Okay, two equal and opposite forces. While explaining, I told you, while opening the cap, so we are applying one force in this direction and other force in this direction. They are two equal and opposite. One action is, line of action is like this, and the other line of action is here in this manner. So two equal and opposite forces which have different lines of action will constitute a couple. Two equal and opposite forces which have different lines of action will constitute a couple. Couple will give us a rotational motion. Okay, so this kind of couple will give us a rotational motion. Next is center of gravity. What is meant by center of gravity? Center of mass we already learnt. What is center of mass? In a rigid body where all the mass is said to be concentrated. All the mass is concentrating at a single point. That is called a center of mass. Here it is center of gravity. What is that center of gravity? It is a point where all the weight is said to be concentrated. All the weight of the object is said to be concentrated. That point is called as center of gravity. Since all the weights are concentrating at a single point, we can do the we can balance this at a single point, right? So this balancing is possible only because we have all the weight is concentrating at a single point. Like this we can concentrate. Okay, so that is center of gravity. All the weights of a rigid body is said to be concentrated at a single point. That is called a center of gravity. Next is another term, that is moment of inertia. So it is the rotational analog of inertia, that is which is a property of mass. Okay, so it is the rotational analog of inertia, that is moment of inertia. Okay, so we can say it is the rotational analog of mass. Okay, this moment of inertia, rotational analog of mass also we can say. Mass or inertia is a factor, is a characteristic property of mass, right? So here we can say it is the rotational analog of mass. So if I am considering what is the equation for kinetic energy in the case of rotational motion, in translational motion, kinetic energy is given as half mv square. Okay, what is this v in rotational motion? V equals r omega. Therefore we can write it as kinetic energy equals half m r square omega square. What is this m r square? M r square is called as moment of inertia. I, half I omega square. Kinetic energy equation in rotational motion is half I omega square. I is called a moment of inertia. Okay, so what will be the unit of moment of inertia? Kilogram meter square. Dimension of I will be equal to ml square, t to the power 0. Okay, so this is r square. Okay, so moment of inertia is the rotational analog of mass. Okay, so I is mr square, that is moment of inertia. So next we should see in all the cases, so for a single particle if I am considering, I can consider it as mr square from the axis of rotation to the point what is the distance. But if it is more than one particle in a system, or if I am considering a rigid body, how we will be considering this r. Okay, so for that, instead of r, I will use another term called a radius of gyration. So one particle means only one distance from the axis of rotation, right? So those cases we can use r, but if we are considering a rigid body, so we know for a rigid body many number of particles are there, isn't it? Like that, and if this is the axis of rotation, each particle from the axis of rotation, the distance is different, right? So it is very difficult to take r in that case. So where should we take for finding out the moment of inertia, that distance? So that distance is called a radius of gyration. So what is the distance? It is the distance from the axis of rotation to the center of mass of the object. That is called a radius of gyration. It is the distance between, distance from axis of rotation, from axis of rotation to center of mass of the rigid body. That is called a radius of gyration. It is the distance from the axis of rotation to the center of mass of a rigid body is called a radius of gyration. It is represented by the symbol K. K is the symbol for radius of gyration. So we can write I for a rigid body is mk square. Okay, so this is the moment of inertia of a rigid body. Moment of inertia of a particle means you can write down mr square. But if it is for a rigid body, it is I equals mk square. K is the radius of gyration, that is distance from the axis of rotation to the center of mass. Unit is meter. Unit in radius of gyration is meters. Okay, clear? So next we are going to study more about this moment of inertia and how we can calculate the moment of inertia. Okay. Next is theorems of moment of inertia. Two theorems are there. They are perpendicular axis theorem and parallel axis theorem. So perpendicular axis theorem is used for a plane lamina. That is, if two dimension is enough for representing a rigid body, then it is this perpendicular axis theorem we can use. This is for a three-dimensional rigid body. Both are for rigid body, we can use rigid body only. This is for a plane lamina. If I am considering a sheet of paper, or if I am considering a disc, in those manner cases we can use the perpendicular axis theorem. So in perpendicular axis theorem, moment of inertia of a plane lamina of a rigid body is moment of inertia of a plane lamina of a rigid body. I am going to calculate in which axis I should consider. I should consider a perpendicular axis. So moment of inertia about a perpendicular axis in a plane lamina is equal to the sum of moments of inertia of the two concurrent axes which is on the plane lamina. Sum of the moment of inertia of the two concurrent axes. Concurrent axis means starting from the same point of the perpendicular axis. If this is a plane, which is if I am considering this as a plane and it is on the plane lamina, I want to find out the moment of inertia perpendicular to this plane lamina. Then I should consider two perpendicular axes on this plane lamina starting from the same point. Of this point itself I should start. Okay, so on the plane lamina I have considered two perpendicular axes, right? Sum of the moment of inertia through those two axes. Moment of inertia about a perpendicular axis on the plane lamina is equal to sum of the moment of inertia concurrent to the perpendicular axis on the plane lamina. So I am considering the two axis. Since it is a plane, I will be having two axes, right? So x and y. It is in the plane lamina. So moment of inertia along x I am calculating, moment of inertia along y I am calculating. I am considering an axis perpendicular to both x and y and concurrent to it. So this z axis I can consider. So it is not on the plane lamina, it is perpendicular like this. Z axis I am considering. Okay, so that will be a moment of inertia about a perpendicular axis on the plane lamina will be equal to the sum of moments of inertia of the two axes which is on the plane lamina. Okay, so Iz will be equal to Ix plus Iy. This is called a perpendicular axis theorem. So it is in this, on the plane lamina, two axes are there. Sum of the moment of inertia in these two axes, that will be equal to moment of inertia of a perpendicular axis concurrent to those two axes. Clear? So Ix is equal to Iz equals Ix plus Iy. This is perpendicular axis theorem. Next is parallel axis theorem. That is, this is a rigid body. It is rotating about an axis I. I is the axis which is rotating. I am finding out where is the position of center of mass. Then moment of inertia of a rigid body about any axis is equal to the sum of moment of inertia of a parallel axis which is passing through the center of mass. Moment of inertia of a parallel axis which is passing through the center of mass and the product of mass of the rigid body and the square of distance between the two axes. This is parallel axis theorem. See, moment of inertia about any axis. Any axis means in which axis it is rotating. See, I can rotate like this, I can rotate like this, or I can rotate it by tilting some angles. Many ways I can rotate the object, right? So moment of inertia of any axis of a rigid body about any axis is equal to sum of moments of inertia of a parallel axis which is passing through the center of mass and the product of mass of the rigid body and the square of the distance between them. Okay, so this is moment of inertia. Okay, clear? These two are the theorems of moments of inertia, and some numerical solved examples are there in the question paper in your textbook, and one full column it's given in your textbook for referring the moments of inertia. Okay, moment of inertia of a disc, a rod, all those many cylinder, all those things it is given as in a table. So all those values please try to study. And two solved examples are there. That too already I did in my theory classes. Previous videos I did already. So if you have any doubt, please check that video. Otherwise you can go through your textbook also. Okay, clear? So the next one is, see, using this moment of inertia, how we can represent the L. L we already got it as L is equal to R cross P. Isn't it? So here I am writing it as R cross MV I am writing. Okay, if R cross M into V is R omega. Okay, if both are perpendicular, if I am considering R and P are perpendicular to each other, then I can avoid this cross, isn't it? So it is M R square omega. What is this M R square? I. L equals I omega. This is another equation for L. Okay, if R and V are perpendicular to each other, velocity in which direction it will be acting? It will, in a rotational object or circular path, it will be through the tangent it is acting, isn't it? So it is L, so R cross P, P is mv, v equals r omega, therefore m r square omega. I got it as L equals I omega. That is also an important derivation. L is equal to I omega. Okay. Next, how I can find out the work done? Work done in a rigid body. Work done, I know it is F dot S. Okay, F means what is this yes. I can represent, how I can represent in this rotational motion, I can represent it as r d theta, F r d theta. Okay, so F into r, if it is perpendicular, means I can write it as F into r is 2 d theta. This will be the formula for finding out the work done for a small distance d theta. dw equals 2 d theta. So these are the, see, in you didn't study any of the derivation till now, but you have a small idea about all those equations and all. Then for this is a representation, actual derivation, everything in detail. This is a shortcut method, or for the final touch, if you didn't study anything, just to score the marks, I am giving some ideas like this. Okay, so actual derivation, everything for your final exam, and actually you should study all those things with the diagrams in that manner only. That is the proper way. So it is given in the description box. All the videos are there. It is given in the description box. But it is, if you didn't touch anything till now, then you can use these shortcuts. Okay, then that is dw equals 2 d theta. Then if we want to find out the power, how we can find out power? Power equals dw by dt. So instead of dw, I can write it as 2 d theta by dt. What is d theta by dt? That is omega, 2 omega. Okay, that is a formula for finding out the power. Power equals 2 omega. So next, it is, I am again starting conservation of angular momentum. So in last video also I did this conservation of angular momentum. You are remembering? That is F tau equals 0, dl by dt equals 0. That is, we can write it as L is a constant. So in this way we explain conservation of angular momentum, right? So but now we got L as I omega, right? I omega. So I omega is a constant. So what is I? M r square omega is a constant. Okay, so this point we can write. For a rigid body, M is a constant. So r square omega is a constant. So what is the meaning of that? If r increases, omega will decrease. If r decreases, omega will increase. So where we will be using this one? See here, in gymnastics and all, while they are rotating, okay, while they are twisting like this, at some moment they will be stretching their hands like this, and that time we can see their rotation, the velocity of rotation will be decreasing. While they are holding the hands together with them, then velocity will be increasing. In circus also you would have seen this. So as distance from the axis of rotation, as the distance increases, angular velocity decreases. As the distance increases from the axis of rotation, as the distance increases, what will happen? Angular velocity decreases. As the distance decreases, angular velocity increases. The same way in somersault also. See, there, and while jumping to swimming pool, first initially they will be holding their legs and hands together with them, isn't it? So they can increase their rotation, isn't it? But when they are coming near to the pole, what they will stretch the hands and legs. So R will increase. If R is increasing, what will happen? Omega will decrease, right? So omega, angular velocity, is decreasing. If otherwise, if it with a higher velocity while they are coming, what will happen? Impulse will happen, isn't it? So a large force will be acting on their body and they will be getting hurt. Okay, so instead of avoiding that, for avoiding that, they will be using this trick. Maybe they know the physics or not, I don't know, but this is the actual reason behind it. Okay, clear? Next we are going to find out the rolling motion. What is rolling motion? Rolling motion means, say, it includes the translational and rotational motion. What will be the kinetic energy in that case? Kinetic energy of translational motion is half mv square. Kinetic energy of rotational motion is half I omega square. Okay, so how we can write down this? We know that half mv square plus half I omega. How we can represent omega in terms of this one? See here, V equals R omega. So what is omega? V square by R square. But we know I is equal to mk square. So instead of I can write it as mk square. So here mv square is common, right? So I can take half mv square outside and inside 1 plus, what is the rest of the things? K square by R square. This is the kinetic energy of a rolling motion. Kinetic energy of a rolling motion is equal to half mv square into 1 plus k square by r square. So these are the important formulas and derivations and theorems. Okay, all the formulas you by heart, and the name laws, conservation of angular momentum, all these are important, very important. So please try to solve all those things, and units also equally important. Okay, so all those 2 videos, if you are understanding properly, then I think you can do it best. You can do your best in for this chapter. Okay, so if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.